Today's lesson is from Unit 2.1, Notes number 10, and it's about the angle bisector theorem. Remember, an angle bisector is a ray that divides an angle into two congruent adjacent angles. So if we take a look at an angle, and then we see a ray, and we'll call that ray AB, we'll know that it's an angle bisector if these two angles are marked congruent to each other, or if we have something in writing that says that angle CAB is congruent to angle DAB. So again, an angle bisector is a ray that divides an angle into two congruent adjacent angles. The first of our two theorems today is the angle bisector theorem, and it states if a point lies on the bisector of an angle, then the point is equidistant from the sides of the angle. So if we take a look at our picture, and you see that the angle A has been bisected by ray AP, you see the markings that tell us that those two angles are congruent to each other. Then we know that point P out here is the same distance from point B as it is to point C. So we can put it into writing by saying if ray AP bisects angle BAC, then line segment PB is congruent to line segment PC. Remember that distance in geometry is always measured along the perpendicular line segment. Our second and last theorem for today is the converse of the angle bisector theorem. So remember, when we write the converse of a theorem, we interchange the if and the then, or that we interchange the hypothesis and the conclusion. So in this case, if a point is equidistant from the sides of the angle, then the point lies on the bisector of the angle. So notice how we're working in reverse. In this case, we know, we can see in the diagram, that line segment PB is congruent to line segment PC. Then we can say that P is on the bisector of angle BAC. In other words, ray AP bisects angle BAC, and then we could add these markings to show that those angles are congruent to each other. Okay, that's it for the notes today. Good luck on the CYU. As always, ask if you have any questions.